Good afternoon, everybody. My name is Joachim Dallinger. I'm responsible for the trade marketing management for EBTA Deutschland. What is the pressure we see everywhere for our business is what is upcoming in the for the new F-gas regulation, and everybody have in mind that we have a lot of time for the phase out, but in reality, the time will run really quickly. We see, special here in 2027, with a big drop for a big reduction for new F-gas, and the second one in 2030. Which will have a dramatic impact on the available of new refrigerants. So that means for domestic refrigeration, it's only allowed to have F-gas below GWP 150, but also for the systems in supermarkets, for example, with a capacity of 40 kilowatt, only GWP at below 150. So, and of course, we have then the natural refrigerants like CO2 and propane and so on, but we have also the low flammable refrigerants. So we have, that's the point for the new equipment. The second point is for the service part. There we have a little bit more time because we can reuse refrigerants which are already in the market, but here also it's a limit. And also there, after 2029, we will see a big reduction. About the refrigerants with the low flammable refrigerants, we see as EBTA not the solution we are following. Why? The point is that all these are 2L refrigerants are PFAS. And these chemicals, when they are in the nature, they will stay forever there. And because of this, we expect there another regulation to jump out of these parts, and so this is not the way we as EBTA are following. So what are the drivers for all this? First, the invest cost. Okay, we need to see the life cycle for a new system, life cycle cost. We need to see about the standard legislation. What about tax? We will see tax for the other refrigerants. We need to take care that the new systems are not too complex, because when we are bringing a new system in the market, we need to take care that the new system is not too complex, so that we can make the service and have the expert there. We need to take care about risk. So also with the flammable and low flammable products, we need to take this in our considerations, and we need to see, is the market ready for technology? So what are the ways we are following on products? First, we have our plug-in cabinets, which all of them are with R290 refrigerants available. We have our remote cabinets with CO2 systems, And there, in the last year, we invest a lot in the development of systems which are also can run in hot conditions. So we developed our FTE system, for example. So the standard in bigger supermarkets for us is transcritical CO2 systems. And on top of that, we developed our integral solution, which we are presenting also on our booth on that Chillventa. So it's a combination of remote cabinets, which you have in the same design, but integrated with a propane unit. And this cabinet can then run air-cooled or with a water loop system. So we think there's not only one solution. It depends on the kind of store you have and on the application. And looking at that, we need to decide if it is a plug-in air-cooled with propane, a remote CO2 system, or an integral solution, for example, water loop. But on all that system, we are going 100% with natural refrigerants. Thank you. That's our point.
Thank you. We take the question afterward for you and for General Gas. Please, the Lillo come here, please, for me. And you are going to talk, Gianluca Lillo, about Internet of Things applied to commercial refrigeration with 455A refrigerant case study. You're talking together? Stefano, you're talking. Okay. Please, 7 minutes, okay? Thank you.
So works? It works? Okay. So listening to the market, we heard about the necessity for energy efficiency solutions, and so we developed after 4 years research an applicative that can help all the installers and the OEM manufacturers to monitor the energy savings and the conditions of the plants. So we decided to develop this application that works in a cloud server and the real-time monitoring of the principal parameters of the HVAC and DAR systems. So basically, it's Internet of Things applied to refrigeration and air conditioning. The system is very quick and easy to be installed. It's made by an electrical connection and processing unit, as you can see clearly. All the data coming from temperature and pressure sensors that are installed through our guide into the system. We collect the data, and through a SIM card we send all the data to a cloud server where there is the real-time processing. So basically, the purpose is to supply to the market a simple tool for a quickest and easy installation that can be done on almost every kind of refrigeration and air conditioning system. So we can go forward. It's like this. So these are simply the main features of the platform. So remote access, even with the mobile phone or with a tablet or with a laptop. Non-invasive installation, because we must avoid any kind of interference with the normal cycling of the plants. And some tools that Gianluca will describe quickly for an advanced diagnosis of what is happening on the plant, and of course with the artificial intelligence supply energy optimization suggestions to be made quickly in the plant to have an high energy efficiency. Now I pass to Gianluca, that is the project engineer of this project, that will describe in a few words what we made for a supermarket that is working, functioning, located in the Sicilia region in Italy. It works with the refrigerant 455A, HUR refrigerant, in direct expansion in the medium temperature side. We installed, after the system was completed, we installed the system. Please, Gianluca. Thank you.
Good afternoon to everybody. My name is Gianluca Lillo, Technical Department of General Gas. Here in the next slides, our case study for commercial refrigeration, low temperature and medium temperature plant for an MD discount with R455A. And this is the list of the measurement instrumentation installed on the plant. Temperature sensor, that is RTD for wire sensor, pressure sensor for low and high side, and current transformers to measure the current absorbed by the compressor rack. This is the component in detail for medium and low temperature. This is an Arneg plant for MD discount. In this case, we install 7 temperature sensor, 2 pressure transducer, and 3 current transformer for each compressor. In this case, there are 3 compressors for plant in medium temperature and 1 compressor for low temperature. This is the information that our system provides to the users. In this case, we can see on the left the chart, the pressure versus the time during the analysis period, and on the right the temperature, the measured temperature versus the time. And this is the same chart for electrical measurement. Not in terms of kilowatt hours, but in terms of supply tension, current absorbed by each phases, and power factor of each phase. So the technician can detect possible malfunctioning in the supply of the plant in the point of view, in the electrical point of view. In addition to the monitoring of the parameter, our system is able to evaluate the performance of the system in real time. Performance meaning COP, electrical and thermal power, electrical and thermal energy. Also the main characteristic parameters of the plant, subcooling, superheating, evaporating and condensing levels, and also the compressor efficiency. So you can see in real time if these parameters are in or out of the optimal range or the desired range. This is the diagnosis and optimization tools inside our system that give information about the possible malfunctioning of the plant in terms of level of the charge, thermostatic valve condition, if the heat exchanger is dirty, is undersized in real time. And also there is an optimization tool where you can see different optimization scenario, so you can evaluate how is the performance in terms of energetic optimization, and evaluate by setting in different way, for example, subcooling, superheating, the evaporation temperature, what is the benefit in terms of saving energy and saving money, so also ambient impact, just in real time. That's all. Thanks for your attention. Yeah.
Thank you very much to General Gas and to EPTA. We are open to questions. We are not many. I know that you want to go home. Do you have any questions about these 2 different topics? One is energy efficiency. It is very important not to look only to refrigerants, but also to energy efficiency. The other is refrigerants. We have a law, we have regulation, we have to stay with GWP below 150. We have a very good solution. So, do you have questions about energy, refrigerant, or comments? So I ask, so what do you think about energy efficiency in comparison to refrigerants?
Well, the energy efficiency is really important. We need to say what we see in the market, that many stores now using also photovoltaic systems, so producing energy by themselves. So, but we see that our customers are still looking on the energy efficiency, and this is also the way where our development is focused, both sides, on the cabinets, but also on the systems. And when we see after many years of the development, we see also with the eco-labeling, what we have now on a cabinet, we see it's always possible to do a little bit more. And this is where we are investing. And it's always good to have systems to monitor this, because if you don't measure the energy, you cannot optimize it.
So the same question to you. What about in your case studies? In your opinion, how much is the importance of energy efficiency than the refrigerant itself? You use A2L, of course, more probably than others. But where do you see the most benefits? Most benefit on energy efficiency or benefits to change the refrigerant?
Thank you for the question. I think that we can evaluate on two different approach, because the use of a specific refrigerant is depending on the specific applications, the operating condition, the load, the thermal load required. But I think that the energy efficiency is very important for all kind of refrigerants you use in the plant. So many times plant give the desired load, but the technician, the manager of the plant is not focused on how good the plant is working. So sometimes there are several percentage point to save energy and use at best the electrical input of the plant.
Yes, I would add one thing, that the Rack Genius Pro is the name of the tool, of the hardware and software platform. And it's necessary not only to have a very good energy efficiency when we start the plant, because we design the plant, we have a COP, we have a seasonal efficiency rate, a yearly efficiency rate, but it's necessary to monitor the performance of the plant during the entire life. That can be 10, 15, even 20 or more years in the industrial refrigeration. And that's a key issue. What can happen? Can happen that the refrigerant being topped into the system could have too much, let's say, oil remaining into the cylinders. And this is valid for every refrigerant. It could happen that there is humidity. In the case of CO2, you can generate carbonic acid. In the case of HFOs, you can generate acidity even. So it's very important to monitor the condition of the plant during the entire life. And this is the purpose of this tool. Not just make a monitoring of, for example, the furniture of the shop. Maybe there is a plug-in that is not working properly. But monitor the whole system in order to prevent any failure or any deviation from the original condition, the project conditions.
Thank you. You want to add something, Joachim, on that one? One more question from you. Do you want to ask one more question? So we leave saying that European Union did an F-gas regulation and eco-design regulation, two regulations that are working, one for energy efficient, one for refrigerants. They are both important, both to be followed, but both sides, energy efficiency and refrigerant, is important. So thank you very much for being here today. See you later.